Let's look at the second question now. The question says, find the greatest length of copper wire that can hang without breaking. The breaking stress is 7.2 into 10 to the power of 7 Newton per meter square. The density of copper is 7.2 gram per cc and G value is 10 meter per second square. Correct? Now again, go ahead, try solving it. So if any of you don't know the formula, I'll just give you the formula once. Then maybe you guys can give it a try. Okay? Now remember, whenever you're talking about, a wire that can hang without breaking, correct? So the breaking stress is basically the weight of the wire by area of the cross section. Okay, so you can note down this particular formula if you want. Alright, so the formula for this is the breaking stress is equal to the weight of the wire divided by area of cross section. Alright, now this is the formula, guys. Now you guys can go ahead, pause the video, solve the problem. Alright, we'll start with what are the things given in the question. Okay, now let's look at it. Find the greatest length that can hang. Okay, so L is what is required. Now what is given? They have given the breaking stress, isn't it? So breaking stress is what? This one. See, this is the breaking stress given. Correct? So what you can write is that S, the breaking stress S is equal to 7.2 into 10 to the power of 7 Newton per meter square. Correct? Density is given. But remember one thing, density you have to convert into SI system, which is kg per meter cube. So what is given? Density is 7.2 gram per cc, isn't it? If you convert it, you will get it as 7.2 into 10 to the power of 3 kg per meter cube if you convert it into SI system. Alright. Now what do we know? That a copper wire is hanging, isn't it? You don't know the longest length. That is what you are trying to find out. Let's say that L is the longest. L is the longest wire. Okay, L is the longest wire. Alright, now see the formula. The weight of the wire by area of cross section. You have to calculate the weight, isn't it? Let's use the formula of density. Now guys, what is the formula for density of a particular body? Density is rho is equal to mass divided by volume. Correct? So mass is equal to volume into density. This is mass, but we want weight. Multiply this by G. So the weight of the wire is equal to V into rho into G. Correct? So this is the formula. Now volume is what? It's a wire, so it's a cylinder. Correct? So since it is a cylinder, the length of the wire into area of cross section is going to give you the volume. Correct? Let's apply that particular formula. So you are going to have W is equal to volume is A into L. A is the area of cross section, L is the length, into rho into G. This is going to give you the weight of the wire. Correct? Now if you apply this over the formula, that is the breaking stress formula, you have breaking stress S is equal to weight, which is A L rho G divided by A. A being the area of cross section. A and A cancels. Correct? Now L is what is required for you. Make L as the subject of formula. So you are going to get L is equal to, so S divided by rho into G. S you know, rho you know, G you know. Correct? Substitute the values. If you are going to substitute, you will get 7.2 into 10 to the power of 7 divided by row value 7.2 into 10 to the power of 3 into 10. See, if you take this, you will get 1000 meters. That means the length of the wire, the greatest length of the copper wire is going to be 1 kilometer or 1000 meter. So the answer for this question is 1000 meter.